Hi, this is Big Data Guy and welcome to Spark tutorial on saving data frames to file. So let's get started. So in previous video, we talked about moving averages on our stock price data, and let's go ahead and quickly store the result of this moving averages into a data frame called result. And let's say you want to store this. What I would recommend is that you go and join all the important data points that you have processed on the stock price data, such as the moving averages, open price, and other important things like weekly high, weekly low, monthly low, etc. column. Create one single data frame and then go and try to store it, because that's the data frame that you could use to go and perform visualization on, right? So I'm just going to be using a simple data frame called result to go and save the data. But in your case, I would recommend that you go and do a little bit of processing on the stock price data on your own based on the functions that we have learned, and then go and try to save the data, right? So let's get started. Now, saving the data in Spark is pretty interesting conversation to have, because there are many different solutions that you could use to save data, right? So you could use CSVs, you could use Parquet file, and I'm going to talk about what exactly Parquet file is. You could talk Avro. I'm also going to talk about that. And you could also use other formats like, you could use text file or ORC or JSON, or you could even store the data to databases like SQL Server and so on, right? Now, each of these storage solution has pros and cons, right? And depending on what your requirement is going to be like, you should be storing data in one format or other, right? So for example, I have created this table to compare the different storage solutions and the ones that is going to be suitable for the situation that you are in, because you're going to be writing a lot of data back to the hard disk, right? Uh, Potentially like terabytes of data if you're dealing with big data and using Spark, and you want to make sure that you write the data in the correct format, so next time when you're going to be reading the data to do further operations, you can read it in fast manner, right? So columnar, what do we mean by columnar over here? Columnar is that can you go and read one single column from the stored data, right? So this allows you to go and say that I only want to read like 5 or 10 columns from the data set that I've stored. And if the data is stored in columnar format, then you would be exactly be able to read those 5 or 10 columns that you're requesting for without reading the entire data set, right? So if you store the data as CSV, because it's not columnar and you want to read like, let's say 10 columns out of like potential 100 columns in your data set, then it will essentially have to read the data row by row. So that means that it's going to load all the 100 columns first, right? So it's going to read all the data that's there in 100 columns, and then, do the subset selection of like, 10 columns that you want, right? And that's not very efficient operation when you're dealing with, think of like, dealing with petabytes of data, right? Not terabytes, like, 1000 terabyte or 2000 terabyte worth of data. You don't want to be reading all the columns that you have. You only want to be reading the columns that you're interested in, right? So Parquet is a solution that will help you achieve that. Like, you can say that I only want to read 10 column from 1000 column that I've stored, and Parquet would perfectly be able to do that, because it saves the column, uh, saves the data in columnar format compared to like, row-wise format, right? So if you know that you have like, too many columns in your data and you have very large data, then, a good solution would be Parquet in that situation, right? Where, and the second comparison point is whether or not it's compressible. Because you're going to be dealing with extremely large amount of data, you want to make sure that you don't store the data as is, because it's going to take up too much space on your hard disk, right? So all of this format are compressible, so you don't need to worry about it. CSV, Avro, and Parquet. CSV is comma separated files, like, right? You can open it in Excel. By the way, if you have like terabyte worth of data and you're going to be opening, you're not going to be able to open it into Excel, right? And Avro is like Apache Avro format, but it has some benefit over CSV, and we're going to look at it later on. Whether or not it's human readable, right? So if you open a particular file, would you be able to read it, right? So with CSV, you would be. With Avro and Parquet, it's not going to be human readable, because it's going to be compressed and it's going to be like formatted in a particular way. You're not going to be able to make sense of the file as soon as you open it, right? And lastly, whether or not it stores schema, right? So in this case, like, when we actually read the stock price data from CSV, everything was read in as strings. And what we had to do, if we go back all the way at the top, You see, everything was read as string. And what we had to do eventually was we had to go and write all these UDFs to actually go and convert our data into the format that we're looking at, right? But now we have processed data, and if we go back and again store it back as strings, it's not going to be beneficial to us. The computation that we performed on potentially terabytes of data is going to be lost, right? So you want to make sure that you store schema after doing such a large amount of processing. In this case, we don't have that large data, but imagine having 1,000 terabyte of data, right? You want to go back and write it as a string, because when you are going to read it back, you'll need to do this processing again, right? Like parsing the correct column, and that's an expensive operation, right? Or you'll need to, when you're reading the file, you need to specify that go and infer schema, and it might not infer it correctly. And if it doesn't infer it correctly, then in that case, you'll need to go and again, redo the processing operation, which is going to be a costly operation anyway, right? So whether or not it stores schema, so for CSV it doesn't, but for Avro and Parquet, yes, it does store the schema. And there are few, there are more than other attributes, more than these attributes that you could compare all these formats on. Like, for example, can it store semi-structured data, right? So in this case, this is tabular data, but you could be dealing with like semi-structured or unstructured, or even like, non-tabular data. Can it store it, right? With Parquet, there's a way around it in which you could store it, but you might need to use JSON, because CSV cannot store semi-structured data, right? So you might need to use JSON in that case. Avro, I think it does allow storing semi-structured data, but I'm not 100% sure, right? And then obviously you could use SQL Server and establish a connection. If you have tabular data, I could write it back to the SQL Server as well, but I'm not going into that much detail over it, because most of the time what's going to happen using Spark is that you're going to be writing to disk, because you're going to be dealing with potentially thousands of terabytes worth of data depending on the company you are at, right? At least few terabyte of data. You're not going to be using that data for transactional purposes, but you're going to be using that data for analytical purposes. So whenever you're using the data for analytical purposes, you would want to store it into a data lake in form of files instead of a database like SQL Server, right? So that's why I'm going over all these different solutions. So because you're going to be working with extremely large amount of data, it's very important that you choose the right solution that is going to fit your use case. And that's why I have, compared what format is going to help you achieve what, right? So to store data into Parquet format is very simple. All you need to do is, let's say, I'm just going to say that we have this result data frame. All you need to do is you just need to say that result dot write, and you could say options, right? So what sort of options that you want to do? So I want to store headers, right? So I'm going to say true, and then I'm going to continue. So let me just do a chaining operation over here, because I want to continue doing this. Now you could use arguments like partition by. So let's say you want to make sure that the data, the way that you split the data is split in a way using a particular partition. So when you read it back, you're going to be able to distribute it pretty well, right? So this is an optimization technique. If you want to use it, like how, if you want to optimize the Spark performance, then you might want to use an argument called partition by. And what happens is that when you say partition by, ticker and parse date, it's going to store all the single stock data on a single hard drive in the format of dates and things like that, right? So when you read it back, it's going to be again like properly partitioned, right? And mode is going to be override. The reason why I'm saying override, ideally you don't want the mode to be override, because if you do this and you mess up, for some reason in real world in the industry, if you perform the override operation, you could mess up a lot of things. You have to make sure that just in case if you're a bug, right? If you're a bug and you perform an override operation, then it could mess up a lot of things, right? So you have to be very careful when you use the override mode, because what it's going to do is it's going to override the previous result that you might have, right? And then if you want to store it as Parquet, then you just write Parquet. If you want to store it as CSV, then you write CSV, right? So I want to store it as Parquet. I'm going to say result Parquet, and I'm going to go and run this operation, right? So let me finish the parentheses to make sure that we are matching parentheses, and I think something goes wrong. Something has gone wrong, my bad. So it says that it should be actually option and not options. Options is like if you want to get like multiple option to the data frame, and now you should be able to store it, right? So now it has gone ahead and stored it instantly for us, right? So let's go and look at like, how it has stored. So if I go over here, it has result.parquet, and you can see it has created all these different files for us, and each of those are by ticker, if you see, right? So we have ticker Apple, we have ticker Amazon, we have ticker BRKB, sorry, BRKB, and so on, right? So it's pretty amazing how it has divided the data by ticker, and we know that ticker is a good way to divide your data by, because each ticker contains equal amount of data, because we have five years worth of stock price data, right? So this is a good partition strategy. So when you're going to read this back, you're going to read this back in an optimal way, right? So similarly, if you want to store the same thing as CSVs, and I'm going to show you how to do that, it's just the last, argument is going to go and, say that I want to store it as CSV. And I'm not going to use parse data in this case. I'm just going to use ticker. And then I'm going to say go and, write a CSV operation, and it was instant. It has gone and done it for me. So let's go and look at the, oh, by the way, I overwrote. So you see, situation like this could happen. I have pretty much overwrote the folder called Parquet, and now I don't have the Parquet data anymore. These are all CSV data. I can go, like you see, like it's a CSV data instead of Parquet, and it only contains 5 data points, because if you notice in the last data frame over here, we have only selected five data points, right? And we have stored that as a result, instead of like, storing all the data points as a result, right? This is just to, make sure that this operation perform faster, right? But if you had all the data, then it would have taken way longer, right? So let me go back and, restore this, actually go and store the moving averages, right? So I'm going to calculate the moving averages over here the way that we have calculated, right? And I'm going to be storing that into entire data set, data frame. All right, so I'm going to say moving average, and then this is the data frame that we have calculated. And then I'm going to go ahead and say that, you know what, go and store moving averages as the result. Instead of result, I'm going to say moving average Parquet. And then this is going to be result CSV, right? So this is, you're going to see like it's going to take way longer to partition this data, because there are lots of data down there, right? So it's going to take that operation way longer to finish in that situation. Now, I want to cover two different functions. One is called Coalesce, and other one is called Repartition, and they're important. And we're going to talk about this when we go about how to optimize the Spark performance. The reason why I'm talking about it over here is that when you are actually distributing the data in your Spark cluster, it is very important that you have data distributed as evenly as possible across your different worker nodes, right? If the data is not distributed evenly across your different worker nodes, then your computation is going to be slow, and you're not going to be able to um, realize the potential of the computation power that you might have, right? So in that case, what you want to be able to do is you want to make sure that you have evenly distributed data. And the way that you could do that is by manually running the partition operation or coalesce operation, right? So repartition operation, sorry, not partition operation, it's called repartition operation. So when you run a repartition operation, what happens is that Spark goes and shuffles entire data, and it makes sure that it repartitions your entire data set evenly across the number of partition that you've asked it to partition by, right? And Coalesce is kind of like an optimized version of partition, but the only problem is that when you use the Coalesce function, uh, your Coalesce, the number of partition that you could create using Coalesce has to be less than what the data has already been distributed on, right? So if you have 1,000 partitions on which the data is distributed on, you cannot go and say that I want to do Coalesce and create 1,200 partition. You can do something like I want to create 900 partition. It has to be less than the number of partitions that are there, and that would be a much more efficient operation of partition, right? So the point that I'm trying to make is that when you're actually storing the data back, you want to make sure that you partition them properly, right? And sometimes you might also want to repartition or coalesce the data to store it into less number of files, right? So by the way, this function is going to keep running for a long time because this operation is going to be expensive. This is not even a large enough data, right? So think about having thousands of terabytes. So when you're doing something like that, don't use partition by when you have large data set, because it's going to take forever to go and perform partition by operation on that, right? If your data is not partitioned properly. So in that case, you might want to go and say that moving average is dot coalesce, right? And then you want to say I want to coalesce in 10 or 9 or whatever number of files that you want to coalesce the data on, and you can go and perform a write operation that is going to be much faster than this, right? Instead of using partition by. So it has taken like forever to finish, right? But however, let me show you what do I mean. Like if I go and say coalesce, I might misspell it, but the whole idea is that let's go and say coalesce, coalesce, and I want to do a 3 partition. I'm not going to do partition by, and then I just want to go and do this, and this is going to be Parquet 3. So let's go ahead and execute this. I've gotten the coalesce as wrong. Yeah, it should be actually right after this, right? So look at this. How fast was this operation compared to this, right? So let's go ahead and look at what we got, right, after this. So if you go and look at this, so moving averages Parquet is partitioned properly based on what we asked it to partition by. So if I go inside of this, you're going to be able to see that it has partitioned. It has stored like thousands of files where you get like partition by ticker and partition by date over here, right? So for each date we have one single file that's going to be generated, and that's an expensive operation to store that, right? So you want to be able to use partition by properly, and in this case you get like 3 different partitions. It doesn't show 3 partition here, but ideally you would get like 3 different partition in that case, right? And it should be like good to go, right? And then result.csv is just result.csv. So within each of the sticker, you're going to get like result, right? The other thing that I want to cover in this tutorial is how do you actually go and read documentation, and then I'm going to perform a separate tutorial on how to go and optimize the performance of the Spark and what are the different things that you could use to optimize the performance of the Spark, right? So let's go ahead and read the Spark documentation. So I'm going to go and search something called Spark documentation in the Google, and the first link is going to be Spark documentation. And you could just go to API docs and say, go to Python, and then in Python you have all different documentation like Spark SQL, Pandas API, and Spark structure streaming, machine learning, so on. So in this case, we're going to go and look at the Spark SQL API reference. And I talked about like some of the functions in Dataframe and things like that. So like let's say if you want to look at all the function in Dataframe, so you could pretty much get all the set of functions that you could perform using Dataframe, or input or output. Like let's say you want to connect to a SQL, then it shows you how you can connect to SQL. I think it would be somewhere over here. The point is that it does show you how do you actually connect to SQL, and so over here .jdbc is a way to connect to SQL, right? Similarly, like let's say you want to, like I talked about window function, you want to know what are all the different things that I could do using window function, then you could go to window function and it tells you like what are all the things that you could do. We looked at range between, rows between function today. We didn't look at range between, but that's one function that you could use, range between. You could use order by, which you already looked at today. You could do all sorts of different things over here, right? And then functions, like all these are all the functions that Spark has inbuilt that you could use to perform variety of operations, right? And then if you want to look at like groupings and UDFs and things like that, then it will tell you like how to do all these things, right? So this is how you read the Spark documentation. It's very well written. It shows you examples and things like that as well. So if I click on dataframe.cache, then it's going to show you how do you actually cache a data frame and things like that, right? So it shows you live example, runnable examples that you could use, right? So anyways, this is how you read the Spark documentation. It's a very well written documentation. And if you want to know more about Spark, Spark function or anything, you could just, ability to read documentation is a good skill to develop, right? So I'm hoping that you could come up with new different functionality that you might want to try out on the stock price data that we have used so far, and pretty much utilize it to perform variety of different operations and go and uh, get yourself more familiarized with Spark. So that's it for today. Hope you have gotten from a very beginner level to now almost intermediate or advanced level, at least in Spark SQL. Um, Thank you for watching the tutorial. Please like, share, and subscribe, and the code will be available on the GitHub repository linked in the description section below. Thank you. This is Big Data Guy. See you in the next tutorial. Thank you.